Today's lesson is on trigonometric graphs, sine and cosine, and today we'll be talking about phase shift and vertical shift. So let's start with the learning objective. My learning objective is I can graph trigonometric functions using phase shift and vertical shift changes by connecting these to previously known transformations known as horizontal shift and vertical shift. Okay, so these are translation transformations, so I'm just moving the object, not changing the shape. So phase shift is my C transformation, or C is my parameter change. So since I am horizontal, I need to measure from the y-axis because I'm going to measure it from here. So I'm going to measure this from the y-axis. And my vertical shift is my D transformation, or my D parameter change. And this is horizontal. I'm going up and down, so I'm going to measure this from my x-axis. Okay, so for my general form here, just a reminder, when I'm talking about the parent function sine, sine is the y-coordinate, and cosine is the x-coordinate. Not sure what happened there. And x is the x-coordinate. Okay, so today we're going to be focusing on C and D. We've already previously talked about amplitude and B, which is the cycles in 2 pi. We talked about amplitude and period, or the cycles in 2 pi. So just a reminder, when we are plotting sine and cosine, so sine, I'm just plotting one rotation of the unit circle. So sine, I'm plotting the y-coordinate. So at 0 radians, I'm on the wave axis. Pi over 2, I'm at the maximum of 1. At pi, I'm back on the wave axis. At 3 pi over 2, I'm at the minimum of -1. And all the way around at 2 pi, I'm back on the wave axis. Okay, so I should be able to draw this pretty easy. I need 5 points to define one cycle. Cosine, I am graphing the x-coordinate. So the x-coordinate at 0 radians starts at the maximum of 1. Pi over 2, I go to the wave axis. At pi, I go to the minimum of -1. At 3 pi over 2, I go back to the wave axis. And at 2 pi, I go back to the maximum. So I like to remember sine is like the shape of an S, and cosine is like the shape of a C. So we're going to be talking about C and D, and sometimes D is at the end, and sometimes it's written at the front of the equation. So I just want to kind of think of this as one term, and D as its own separate term to help you understand. I put D at the front, so when I'm putting things in my calculator, when I'm doing my applications later in the unit, it's easier to enter in the calculator. So correct-wise, I usually show it as the second term, but to put it in the calculator easier, I'll usually list it first because it just makes it less complicated. All right, let's do some examples here. Okay, so the phase shift is what would be called the horizontal shift for standard transformations. So this is a horizontal transformation, so I call this backwards. So x minus c means I'm going to go to the right c units. And x plus c means I'm going to go to the left. C units. Okay, so today I am focusing on the C parameter, C transformation. We usually call them parameter changes for trig instead of transformations. So C is going to be what I'm adding or subtracting to my variable. Okay, so what does this look like? So let's start out with, let's name, I already know what A and B are from a previous lesson. So A is amplitude and B is the number of cycles in 2 pi. So let's review that. So since I have nothing written to the left of the trig word, that is assumed to be 1, so my amplitude is 1. There's nothing written to the left of the variable. So the number of cycles in 2 pi is 1. And I want to just remind you that the form is x minus c. So when I am saying x minus c, c is actually pi over 4. So x minus c is the form I need to be subtracting. So when I'm saying x minus something, I know I am moving to the right. So my standard, so I'm looking that I have a sine curve. So my sine curve starts on the wave axis, goes to a maximum, comes back to the wave axis, goes to a minimum, and comes back to the wave axis. I need to move right pi over 4. So I'm looking at that I have one box represents pi over 2. So pi over 4 is a half of a box. So I'm going to take each of my 5 points and move them to the right a half a box. So my phase shift is my horizontal shift. Okay, let's do another example. Y equals cosine of the quantity x plus pi divided by 4. So my amplitude A is 1. Number of cycles in 2 pi is 1. And this says x plus pi over 4. So if it helps to think of this as x minus a negative pi over 4, because a minus is a plus. So I know c is negative pi over 4. So I said x plus pi over 4, so I'm going to the left on this one. So cosine looks like the shape of a C. So I start at a max. I go to the wave axis, the minimum. I come back up to the wave axis and return and finalize at the maximum. So this time I want to move to the left a half a box. So again, I'm still same. Pi over 2 is 1 box, so pi over 4 is a half a box. So I'm going to move each of my 5 key points left a half a box. Okay. Okay, so that covers C, called phase shift. As your transformations, you learned it as the horizontal shift. Same thing. Okay, my next transformation or parameter change is D, which is my vertical shift. So x plus D shifts me up D units. And x minus D, I'm going to go down D units. Y equals D is my wave axis. So this is my D parameter. I'm going to talk about, and this is a separate term, so it is not connected to the trig word. So mathematically, we show it at the end of the equation, but I'm going to show you what it looks like at the front. All right, so let's graph y equals sine of x plus 2. Just to review all the parameters, A is my amplitude, which is my coefficient to the left of the trig word. So my amplitude is 1. It is always positive. B is the number of cycles in 2 pi. That is to the left of my variable. So B is 1. C is part of the trig word. It would be x minus c. It is not there. So when I'm adding or subtracting, that is 0. So here's A, B, and this is D. D is a separate term. So my D value here is 2. Okay, so I'm starting out by looking at that I'm looking at a sine wave. So a standard sine wave starts at the wave axis. I go to a maximum, come back down to the wave axis. I go to the minimum, and I return to the wave axis. So this is my standard sine wave. So I am going to put my wave axis, which is at y equals 2 on my graph. And my shift says I'm going to move all 5 of my points up 2. So here I'm going to go 1, 2. I'm going to go 1, 2, 1, 2, 1, 2, 1, 2. Here we go. So we are going to always label our final graph. Okay, so another way I could see this is I could see the D term in the front of the equation. So D is a separate term, so I'm adding or subtracting it to the trig term. So A, B, and C are all connected to the trig term. All right, so let's put all 4 transformations together now. Okay, all 4 transformations, or we can call them parameter changes. Okay, the first thing I'm going to do is find the period and divide the x-axis into 4 equal parts. I want to decide what the amplitude is. I'm checking, is there a negative sign? Does it flip? And then I'm going to plot A and B, my 5 points, using period and amplitude. And then I'm going to check for the phase shift. And I am going to check for the vertical shift. And I'm going to label the 5 points. All right, so let's get started here. So y equals 3 cosine pi over 4 times the quantity x minus 3 plus 2. So I'm going to suggest I would label A, B, C, D up in my equation so I'm really clear. So my amplitude A is 3. The number of cycles in 2 pi is pi over 4. So this is B. C is 3. So this is my phase shift. And D is 2. So the first thing I want to do is find the period. So the period is 2 pi divided by B. So 2 pi divided by B, and we said B is pi over 4. So this is 2 pi divided by pi over 4. So when I divide fractions, I flip and multiply. So this is 2 pi times 4 divided by pi. So I'm multiplying numerator times numerator, and I know pi divided by pi is 1. So 2 times 4 is 8. So the period, so for one cycle, it is 8. But I want to divide this into 4 parts. So my increments are going to be 8 divided by 4 is 2. So horizontally, I'm counting by 2's. So this is going to be 2, 4, 6, 8, 10, 12. Okay, so next I decided, so that is my period, and then we said my amplitude is 3. So I want to plot period and amplitude first. So I'm counting horizontally by 2's, but vertically I can just count by 1's. So I'm going to label these as 1, 2, 3, 4, 5, 6, -1, -2, -3. Okay, so I am plotting a cosine. So a cosine looks like a C. So I know I'm going to plot something that looks like this first. So I'm starting at the maximum, which is 3, wave axis, minimum, which is -3, back to the wave axis, and back to the maximum. Okay, so I've plotted 2 parameter changes, A and B. Now I want to plot the other 2, C and D. So we have 3. So here I have A is 3, we said. Oops, here this will be 4. So step 4 is C. We said C is 3. It is X minus C, so I'm going 3 to the right. So I am counting by 2's. So since I want to go 3, this is 1.5 boxes. So I'm not labeling the boxes. So when you don't label the boxes, then you're not telling me all the information. So make sure you label the horizontal and the vertical axes. Okay, and then we said D is 2. So D is 2, so that means I'm going up 2. And I'm counting by 1, so I'm really going up 2. So I'm going right 1.5 boxes and up 2. Right 1.5, 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 up 2. And we said the wave is at y equals d. So d is 2, so the wave axis is here. So I really want you to label the wave axis too. So this is y equals 2. Here's my points. I'm going to tell you this is my final graph, so it's not a mystery which graph I'm looking at. I have my x-axis labeled. I have my y-axis labeled. So it's very clear what my graph represents. All right, let's try another one. All right, let's go to red. I'll do that first. Okay, y equals -2 sine 4 times the quantity, x plus pi over 4 minus 2. So I'm going to start by labeling A, B, C, and D. So I know A is 2. I have a negative sign in front of A, so that means I'm flipped. B is what I'm multiplying times the variable. So B is 4. So I know I have 4 cycles in 2 pi. This says x plus 4. So another way of thinking about this is x minus -pi over 4. So I know C is -pi over 4. And D is -2. So I start by calculating the period. So the period is 2 pi divided by B. So 2 pi divided by, we said B is 4. So simplifying my fraction, I get my period is pi over 2. Next, I want to know what my increments on the boxes are. So I want to take my period and divide it by 4. So this is pi over 2 divided by 4. So I flip and multiply. So this is pi over 2 times 1 over 4. So I multiply numerator times numerator. So pi times 1 is pi. Denominator times denominator. 2 times 4 is 8. Next, I want to know my amplitude is. I said our amplitude is 2. Since I have a negative sign in front of the amplitude, that means I'm flipped. So I am graphing sine, but I'm flipped. So I know I'm going like this. So just to kind of get an idea what I'm graphing. So let's graph that. So I know I am counting by pi over 8. So each box horizontally is pi over 8. So here's pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. So each horizontal box is pi over 8. Vertically, I'm just going to count by ones. So 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5. Okay, so I'm going to plot my amplitude and period together first. I'm doing a flipped sine. So I'm starting at the wave. I am going to the minimum, coming back to the wave, going to the maximum, coming back to the wave. So here's my first 2 parameters graphed. All right, so let's add my C and D parameter changes. So we said C equals negative pi over 4. So I'm x plus 4. So plus 4 means I am going to the left. So a fourth is going to be 2 boxes. So each box is 1/8. So if I simplify these, 2 pi over 8 is pi over 4. 3 pi over 8 is okay as is. And 4 pi over 8 is pi over 2. So I need to simplify my fractions. But I know pi over 4 is 2 boxes. And my D value is negative 2. So I'm going to go down 2 boxes. So my wave axis is at y equals negative 2. So I'm going to take each point and go left 2 and down 2. So left 1, 2, down 2. 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 Okay, here we go. Drawing my curve smooth. And I want to indicate what I'm looking at as my final graph. Okay, just a quick review on the back. I need to memorize what all the transformations are. Again, you have to figure out what strategies work for you. I like drawing the goalposts. So I know my amplitude, which is my A transformation or parameter change, and my vertical shift are both normal. And my B and C transformations, so the number of cycles I have in 2 pi and my phase shift are backwards. I need to remember what everything is called. So trig has a lot of its own vocabulary. So A is amplitude. B is the number of cycles in 2 pi. And that's related to period. the horizontal length for one cycle. C, instead of calling it the horizontal shift, is now called the phase shift. And I measure this from the y-axis. And the vertical shift is measured from the x-axis.